So we're going to be looking at comparing the sizes of fractions and arranging fractions in order of size. The skills you're going to need, you need to be comfortable with your multiplication tables. You need to know about equivalent fractions, which I covered in a previous video. And you also need to understand what is meant by the lowest common multiple. Again, this was something that I covered in another video. Now, when you were introduced to fractions, you probably got to draw different fractions, and you could see or compare the size of fractions by shading in shapes, as shown here. We can see that a half is bigger than a third, is bigger than a quarter, because the area that is being shaded is larger. But what about these two fractions? Which is the largest, 2/3 or 3/4? Well, we could use some squared paper, draw two shapes of the same size, and shade in the appropriate amount. And we can see that 3/4 is larger than 2/3, because the area showing 3/4 is larger than the area showing 2/3, provided, of course, the shapes that we are finding the fraction of are the same size. But we're going to use a less visual approach in order to compare the size of fractions or to order fractions. Let's stick with this example, even though we know what the answer is. The challenge in trying to determine which is the larger of the two fractions is the fact that the denominators are both different. If the denominators had been the same, so let's say, for example, we had 1/4 and 3/4, well, we know that 3/4 is bigger than 1/4. But this time we are comparing 2/3 with 3/4, where we are dealing with a denominator of 3 and a denominator of 4. So what do? Well, this is where we need to know about the lowest common multiple. That is the lowest multiple that is common to both 3 and 4 in this case, as these are the denominators of the two fractions we are comparing. Well, looking at the multiples of 3, well, we know we have 3, 6, 9, 12, 15 and so on. And for 4 we have 4, 8, 12, 16 and so on. And we can see that the lowest common multiple is 12. And in order to compare the two fractions, we are going to write both fractions as equivalent fractions out of 12. I'll show you what I mean. So we have 2/3 is equal to something over 12. Now remember, when doing equivalent fractions, if we wish to maintain the ratio between the numerator and the denominator, then we have to multiply both the numerator and the denominator by the same number. In the case of 3, remember 12 is a multiple of 3. 3 multiplied by 4 is equal to 12. If we multiply the denominator by 4, we therefore have to multiply the numerator by 4. So 2 multiplied by 4 is equal to 8. So 2/3 is equivalent to 8/12. Similarly, if we look at 3/4, well, this is equal to something over 12. Well, 4 multiplied by 3 is equal to 12. So we have to multiply the numerator, which is 3, by 3 as well. So 3 multiplied by 3 is equal to 9. And so 3/4 is the equivalent to 9/12. So we can easily compare 2/3 and 3/4. 2/3, which is 8/12, and 3/4, which is 9/12. Well, 9/12 is greater than 8/12, which means therefore that 3/4 is greater than 2/3. This lowest common multiple, which we are using as the common denominator, is referred to as the lowest common denominator. And for the more eagle-eyed amongst you, you probably noticed that the lowest common denominator was generated by multiplying the denominators of the two original fractions. That is, 3 multiplied by 4 is equal to 12. But hopefully for some of you, finding the multiple that is common to both 3 and 4 was quite easy. Hopefully you knew that the answer would be 12. And as I keep on saying with this fraction work, it is important to be confident with your multiplication tables. Let's look at another example. Which is the largest, 7/9 or 5/7? Well, let's look at the denominators. Are they the same? Well, the answer to that is no. So we need to find the lowest common denominator, or the lowest common multiple, to both 9 and 7. Now, if we start listing the multiples for both 9 and 7, so for 9 it's 9, 18, 27, 36, 45, and so on, and for 7 it's 7, 21, 28, 35, 42, and so on, this can start to take time. But in this particular example, as with the previous example, we can find the lowest common denominator by just multiplying the two denominators together. So that's 9 multiplied by 7 is equal to 63. And if we were to continue finding the multiples of 9 and 7, we can see that the lowest common multiple, or the lowest common denominator, is 63. So we can now find equivalent fractions for both 7/9 and 5/7 as fractions out of 63. So 9/7 is equal to something over 63. Well, remember, 9 multiplied by 7 is equal to 63. If I multiply the denominator by 7, I have to multiply the numerator by 7. Well, 7/7 is equal to 49. So 7/9 is equal to 49 over 63. As for 5/7, well, 5/7 is equal to something over 63. 7 multiplied by 9 is equal to 63. I now have to multiply the numerator by 9. Well, 5 9s are 45. We can now easily compare our two fractions, 49 over 63 and 45 over 63. Well, 49 over 63 is larger than 45 over 63, so 7/9 is greater than 5/7. Let's look at this question here, which is the largest, 13/15 or 4/5. Are the denominators the same? And the answer to that is no. We have 13/15 and we have 4/5. What is the lowest common denominator, or lowest common multiple, to 15 and 5? Well, what's good here is that 15 is actually a multiple of 5, which is good news, as we therefore don't need to find an equivalent fraction for 13 over 15. We can leave that as it is. What we need to do is to convert 4/5 into a fraction out of 15. 5 goes into 15 3 times. If I multiply the denominator by 3, I have to multiply the numerator by 3. 4 multiplied by 3 is equal to 12. So we have 13/15 and 12/15. Well, 13/15 is greater than 12/15, so 13/15 is greater than 4/5. I'd like to point out at this time, I've been writing what I'm multiplying the numerator and the denominator by. You don't have to do this. I'm doing this more to help explain what I'm doing for your benefit. But if it helps to put these arrows in to explain what you're multiplying the numerator and the denominator by, then by all means do it. Here's a similar question. Which is the largest, 19/24 or 5/6? So are the denominators the same? And the answer to that is no. But we can see that 24 is a multiple of 6. So in order to compare the two fractions, all we need to do is to write 5/6 as something out of 24. 6 multiplied by 4 is equal to 24. If I multiply the bottom by 4, I have to multiply the top by 4. 5 multiplied by 4 is equal to 20. So we have 20 over 24. Well, 20 over 24 is greater than 19 over 24, so 5/6 must be greater than 19/24. Let's order some fractions. Just have a look at the question. Arrange these fractions from smallest to largest. We're going to apply the same principles as we applied in the previous examples. It's just that we have more than two fractions this time. The denominators of the fractions are not the same, so we need to find the lowest common denominator of these 5 fractions. If you know your multiplication tables, you might actually know what the lowest common multiple or lowest common denominator is. But let's start listing the multiples of the various denominators. I'm going to start with the denominator of 2. So we have 2, 4, 6, 8, 10, 12, 14, 16, so on. For the denominator of 3, we have 3, 6, 9, 12, 15, 18, and so on. And the denominator of 4 produces 4, 8, 12, 16, and so on. Well, we can see that 12 is actually a common multiple of those 3 numbers. So our lowest common denominator is actually 12. I'm hoping that you might have noticed that 12 is a multiple of 2, a multiple of 3, and a multiple of 4. Now that we know what the lowest common denominator is, let's write equivalent fractions for a half, 3/4, and a third. So a half, well, 2 multiplied by 6 is equal to 12, and 1 multiplied by 6 is equal to 6. So we have 6 over 12. For 3/4, well, 4 multiplied by 3 is equal to 12. I therefore have to multiply the numerator by 3 as well. So 3 multiplied by 3 is equal to 9. So 3/4 is equal to 9/12. Now for a third, 3 multiplied by 4 is equal to 12. What I do to the denominator, I must also do to the numerator. 1 multiplied by 4 is equal to 4. So we end up with 4/12. So writing these fractions out of 12 in order, we have 4/12, 5/12, 6/12, 7/12, and 9/12. So writing the original fractions in order of size smallest to largest, we have a third, 5/12, 1/2, 7/12, and 3/4. Arrange the following fractions from smallest to largest. We have 2/5, 5/6, 11/15, and 9/10. We can see that the denominators are not the same. What's the lowest common denominator? What number is a multiple of 5, a multiple of 6, a multiple of 15, and a multiple of 10? If you're confident with your multiplication tables, you might already know the answer to this. But let's quickly write out the multiples. The multiples of 5 are 5, 10, 15, 20, 25, 30, 35. For 6, it's 6, 12, 18, 24, 30, 36. For 15, we have 15 and 30, 45. And for 10, we have 10, 20, 30. We don't really need to go any further. We can see that the lowest common denominator is going to be 30. 30 is a multiple of 5, because 5 times 6 is equal to 30. 30 is a multiple of 6, because 6 times 5 is equal to 30. 30 is a multiple of 15, because 15 times by 2 is equal to 30. And 30 is a multiple of 10, because 10 times 3 is equal to 30. So let's use this information and write all these fractions as equivalent fractions out of 30. So for 2/5, well, we multiply the top and bottom by 6, and this gives us 12/30. For 5/6, we multiply the top and bottom by 5, which gives us 25/30. For 11/15, we multiply top and bottom by 2, which gives us 22/30. And for 9/10, we multiply the top and bottom by 3, which gives us 27/30. Let's order these fractions. We have 12/30, 22/30, 25/30, and 27/30. and rewriting them as their original fractions, we have 2/5, 11/15, 5/6, and 9/10. Let's do one more question. Arrange these fractions from smallest to largest. 11/16, 3/8, 5/8, a half, 7/16, and 1/4. So if we look at the denominators, are they the same? And of course the answer to that is no. But can we find a lowest common denominator of those denominators? I'm not going to list out the multiples this time because I'm comfortable with my multiplication tables. I know that 16 is a multiple of 2, 4, and 8, which are the other denominators. So the lowest common denominator must be 16. So let's list our set of fractions as fractions out of 16. So we have 11/16, we don't have to do anything there. 3/8 is equal to something over 16. Well, 8 multiplied by 2 is equal to 16. I therefore have to multiply the numerator by 2. 3 times 2 is equal to 6. Now for 5/8, well, 8 times 2 is equal to 16. So the numerator has to be multiplied by 2. So 5 times 2 is equal to 10. Then we have a half is equal to something over 16. Well, that something must be 8, because for a fraction to be equivalent to a half, the denominator is twice the numerator, and 2 times 8 is equal to 16. We then have 7/16, and then we have 1/4 is equal to something over 16. Well, that something must be 4. Remember that for a quarter, the denominator is 4 times greater than the numerator, and 16 is 4 times greater than 4. 1/4 must equal 4/16. Placing these fractions in order, we have 4/16, 6/16, 7/16, 8/16, 10/16, 11/16. And finally, rewriting the original fractions, we have a quarter, 3/8, 7/16, a half, 5/8, and 11/16. So that's all I'm going to be covering on ordering fractions in this video. So get plenty of practice. Keep learning your multiplication tables. This is key to understanding this work. If you struggle with your multiplication tables, you're going to struggle to find the lowest common denominator. But I hope you found this video helpful, and thank you for watching.